Hi, hello, vanakkam, and good morning. This is Vignesh, uh, working as an assistant professor in Department of Mechanical and Mechatronics Engineering in SNS College of Engineering. And in this lecture series, we are going to mainly talk about the heat and mass transfer. It is for especially for mechanical engineering students, where this subject is very much essential, and understanding the concept of heat transfer is very essential in order to develop some applications like air conditioning systems, power plants, and boilers. So these are all the applications that which we are using in our day-to-day life. So it is like it evolves, or it has a basic principle of heat transfer. So we need to understand what a heat transfer means. Okay, so heat and mass transfer are fundamental processes that govern energy and material transport in a wide range of natural and engineering systems. See, in general, without heat, there won't be any work is possible. Okay, so heat is a very essential thing. So, when will this transfer of heat happens means you have two separate things, that is high temperature region and lower temperature region. You know that what is the difference between the heat and the temperature, right? So heat is form of an energy, and temperature is like it is a property which is used to measure the materials hotness or coldness. So it is two different things. So when will this heat transfer means you have a high temperature region and lower temperature region. So if you have these things in your system, then automatically heat flows from higher temperature region to lower temperature region, so without any external aid. That is the most important thing. So these principles define how energy in the form of heat and substances like fluids, that is liquids or gases, move from one location to another. So understanding this phenomena is essential for optimizing design, improving efficiency, and driving innovation across multiple fields. Okay, so let us explore this. So first one is power plants. Okay, so in general, we are having a power plant which is used to generate electricity. How the power plant operates, like in the form of like converting or uh, converting one form of energy, that is heat energy, into another form of energy like electricity. So, in order to improve the efficiency of a power plant, we need to understand the heat transfer mechanisms, especially in boiler, where the water gets heated and it's converted into a steam. Then this steam goes to the turbine. It gets rotated by the turbine gets rotated with the help of steam, and with the help of generators, we are converting heat energy into electricity. So, if you want to improve the efficiency of a power plant, you need to understand the heat transfer mechanisms in the power plant. And if you go for like a design of electronic systems, definitely electronic system will generate heat, right? So, if you didn't remove that heat generated by the electronic components, automatically the electronic systems will fail in future. So, like heat sinks and liquid cooling systems for CPUs and GPUs are critical for maintaining the performance and reliability of an electronic system. So, those heat generated by the electronic system should be removed from that system in order to keep the efficiency, or in order to keep the devices working. Okay, so this cooling is very essential in electronic systems. And HVAC, like it is ventilation and air conditioning system, where we depends on in summer season, we depends on mostly on the uh, uh, air conditioning systems. So heat pumps and air conditioning, heat exchangers, typically their basic principle is the heat transfer mechanisms only. And other applications, like it is in chemical and food processing industries, distillation, drying. So these processes will depend on the heat and mass transfer mechanisms in distillation, separating components in chemical mixtures such as petroleum refining process like gasoline, diesel production, where the heat is applied and crude oil gets converted into multiple products like gasoline, diesel, natural gases, something like that. And for that, heat transfer mechanism is very very essential. And heat transfer generally affects the monsoon system also. If you study the climate modeling, where the air tends to move from high temperature, high pressure region to low temperature, low pressure regions. So our climatic systems will generally based on the heat transfer mechanisms. And pollution control, like designing systems for removing pollutants from air and water such as scrubbers in power plants and wastewater treatment plants, also have a pivotal role in the heat transfer. So emerging application like in biomedical engineering, designing drug delivery systems and artificial organs, leveraging microfluidic devices and heat transfer in implants, improves patient outcomes and advances in medical technology. And 3D printing also, we have an application, heat transfer application in it. And energy storage is very very essential if you go for renewable energy systems. So using phase change materials and concentrated solar power improves energy efficiency and reduces reliance on fossil fuels. So these are all the emerging applications where we can use the heat and mass transfer uh, knowledge. So that's it for today. Thank you for watching.